Hello friends, welcome to my channel Technical Classes of B. This is my second video. Yesterday I have uploaded the first video about the microprocessor. If please watch my video. If you think the video is beneficial to you, then please like my video and also don't forget to subscribe my channel. Today this is my second video which is related with the 8086 microprocessor. In this video, I will explain about some introduction of 8086 and the architecture of 8086 microprocessor. So let's start. Now microprocessor is one of the electronic chip which is present your motherboard and which accept the input from user, process it according to the instruction and store the result in memory or provide the result as a output to user. Okay, this is the definition of microprocessor. So I will repeat. Microprocessor is a multi-purpose programmable device that accepts digital data as an input, process it according to instruction stored in its memory and provide result as a output. Okay. Now the features of microprocessor. In the previous video I told you about the evolution of microprocessor. In that I explained the 4-bit microprocessor, 8-bit microprocessor, then after 16-bit, 32-bit and 64-bit microprocessor. Today the 8086 microprocessor is we are studying. The 8086 microprocessor is a 16-bit microprocessor. Means this 8086 processor can execute 16-bit data at a time. Okay. So the instruction written by using the 8086 processor contains the two register, which is one is 8 bits and second is also 8 bit, means the total data is 16 bit and this processor execute the 16 bit data. Second feature of this processor is it has a 16-bit data bus. So it can read data from or write data to memory and ports either 16-bit data or 8-bit at a time. The third feature of 8086 is it has 20-bit address bus. Okay, address bus of 8086 is 20-bit. Fourth number is it can support up to 64 kilobytes I/O ports. Okay. The fifth feature is it provide 14 and 16-bit register. There are number of register present in 8086 processor architecture, which I will tell you in the next slide. Okay. So it provide 14 and 16-bit register. Sixth number feature is it has multiplexed address and data bus. It requires single phase clock with 33% duty cycle to provide internal timing. Prefetches up to 6 instruction byte from memory and queue in order to speed up the processing. Means it can fetches 6 instruction byte at a single time. So the speed of execution is increases. And the last feature of 8086 is it operates in two mode. First is the minimum mode, second is the maximum mode. So what happen in minimum and maximum mode, that we will see in the next video. Okay. So these are the features of 8086 microprocessor. Now Now we will study the architecture of 8086 microprocessor. This figure shows you the architecture of 8086. Okay. The architecture of 8086 is divided into two parts. First is the BIU and second is the EU. BIU for bus interface unit and EU for execution unit. As the figure shows, in bus interface unit there are 5 registers, that are ES, CS, SS, DS and IP. Also, bus interface unit contain instruction stream byte queue, okay, and some of the internal buses. The execution unit contains arithmetic and logical unit, then flag register, then some general purpose register and some pointer and index register. General purpose register are AH, AL, BH, BL, CH, CL, DH, DL. These 4 are general purpose register, and SP, BP, SI, DI are pointer and index register, and all these register are 16-bit register, okay, because the 8086 processor is a 16-bit processor. So first I will explain the bus interface unit. The function of bus interface unit is to handle the data and transfer the data between the processor and memory or IO devices. Also, bus interface unit is used to compute and send the addresses of the data. The third function of bus interface unit is to fetch the instruction code and store it in the queue. Then it read and write data from memory or input output devices. Okay. Also, bus interface unit relocate the addresses. The bus interface unit tell the execution unit from where the instruction fetched or read the data. All these are the function of bus interface unit. Okay. Again I will explain. The first function of bus interface unit is handle data and transfer it between the processor and memory or IO devices. It compute and send out the addresses of data. It fetch instruction code and store it in the queue. It read and write data to or from memory or IO devices. Also, it relocate the addresses. The bus interface unit tell the execution unit from where he has to fetch the instruction or read the data. Okay. Now we will come the second part of the architecture, that is execution unit. The function of execution unit that it receive the opcode from bus interface unit. Okay. Opcode means operational code of your instruction. Okay. It receive the opcode from bus interface unit, decode that instruction and execute it. First, it receive the instruction from bus interface unit, decode that instruction and execute that instruction. When the execution unit decode the instruction, the bus interface unit fetches instruction code from memory. Okay. When execution unit Decoding the instruction, the bus interface unit fetches instruction code from memory and stored it in the queue. So, the execution unit and the bus interface unit both are operate in a parallel but independently. Okay, both bus interface unit and execution unit operate in parallel but independently, and this make the faster execution of data or instruction. Okay, due to the parallel and independent execution of both the parts, the speed of the processor is increases, means the execution of instruction gives output quickly. So the execution unit execute instruction and bus interface unit fetches the instruction, and this type of overlap operation of microprocessor is called as a pipelining. Okay, this type of overlap operation of microprocessor is called pipelining. This is the new concept. Okay, again I will explain. The execution unit execute instruction and the bus interface unit fetches instruction, and this type of overlap operation of processor is called as a pipelining. So this is about the function of this microprocessor. Okay, now there are number of register in this architecture, such as general purpose register, flag register, pointer and index register. Again there is a stack register, instruction pointer, queue. Okay, all these register I will explain in the next video. Okay, so friend, please tell me uh, what about the video. If you like my video, then please like it, and also don't forget to subscribe my channel. Thank you.